Okay, so if anybody ever wondered what happens when Mrs. Chemers is recording on her iPhone and she gets a phone call, the answer is it stops the video, which is why that last video stopped abruptly. Anyway, let's look at number 2. So when we look at number 2, we want to come up first with the vertex. So this is in the form of y equals a times x. Well, in this case, sorry, a is 1, x minus 0 minus 4. So my vertex is 0, negative 4, which means my domain is x is greater than or equal to 0 and y is greater than or equal to negative 4. And since the only thing that changed was the vertex and a is still 1, this is a translation. Now, looking at number 3. If I put it in the form of y equals 1 times x minus 1 plus 0, that means my vertex is 1, 0. And again, it's just a translation, since it's just a translation because a equals 1, and x is greater than or equal to 1, and y is greater than or equal to 0 is my domain and range. Now, here, again, a is 1, so this is just a translation. This vertex is negative 3, negative 2, so x is greater than or equal to negative 3, y is greater than or equal to negative 2. Okay? Now, if we look at number 5 is a vertical stretch. Why is it a vertical stretch? Because a is greater than 1. So this is a vertical stretch because a is greater than 1. Okay? What's the vertex here? Well, we're not adding anything to x, we're not adding anything to y, so the vertex is 0, 0. Now, let's look at the next one because there's a lot going on. Now, we know the vertex is going to be negative 3, negative 2. We know this is going to be a reflection and a stretch. The curious thing here now is, though, why do you think the domain is x is greater than or equal to negative 3, which is what we expected? Why all of a sudden now is my range less than negative 2? Well, that's because if it's reflecting, it's going to go like this. And so that means all of your y values are going to be lower. So just be careful. When it's a reflection, y is less than something instead of greater than something. This makes it a shrink. This vertex is 5, 2, and the domain is x is greater than or equal to 5, y is greater than or equal to 2. Okay? So now, let's turn to page 2a, and we're going to go over graphing. We're going to go over graphing using a chart, and we're going to go over graphing using a shortcut. Okay? Now, when you graph, you always start with the vertex because this has an endpoint. You must include your endpoint or else your graph, you'll miss part of your graph. So the first thing you always do before you graph a square root function is figure out the vertex. We start our chart with the vertex. Then I'm going to pick numbers that I can easily take a square root of. So I pick 1, 4, and 9. So this square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Now notice this goes up 1, up 3, up 5. I want you to notice that because that's going to be a common pattern that we see. Now let's graph these. We have 0, 0, 1, 1, 2, 3, 4, 2, 5, 6, 7, 8, 9, 3. Okay, and I want you to notice something. If I turn it sideways, it looks like half a parabola, right? Notice I go over 1, up 1, over 2, up 4, over 3, up 9, right? Over 1, up 1 squared, over 2, up 2 squared, over 3, up 3 squared. So it has a pattern just like the quadratic function had a pattern. Let's see if we can figure out what that pattern is. Well, I go up 1, over 1. Up 1, over 3. Up 1, over 5. Okay, now notice over here, I went 1, 3, 5. Okay, so the shortcut way of graphing this is you start at the vertex, you go up A, whatever A happens to be. In this case, it's 1. And then over 1. Up A over 3, up A over 5. That is the shortcut, which you don't have to use. You can just plug in values, but it is a shortcut. So let's see how the next one looks and if we can use a shortcut. Okay. Now, for the next one, y equals 1/2 the square root of x. Again, always start with the vertex. The vertex is 0, 0, because I'm not adding anything to x. I'm not adding anything here. I could actually make it like that for those of you who don't see the vertex. So I start with 0, 0. I pick numbers that are perfect square, but I notice this is +1, +3, +5, right? Now, when I plug this in, square root of 1 is 1, half of 1 is 1/2. Square root of 4 is 2, half of 2 is 1. Square root of 9 is 3, and this becomes 1/2. So let's graph those numbers. 0, 0, 1/2, 2, 3, 4, 1, 5, 6, 7, 8, 9, 1/2. So this is a shrink because it's closer to the x-axis. But let's try the shortcut method. Now the shortcut method says go up A. In this case, A is 1/2 over 1. Up A, which is 1/2 over 3. And up A, which is 1/2 over 5. Let's see if it works. We go up 1/2, start here. Up 1/2 over 1. Up 1/2 over 3. Up 1/2, 1, 2, 3, 4, 5, over 5. And the shortcut method works, okay? So for these, you can use the shortcut method. Start at the vertex. You go up A over 1, up A over 3, up A over 5. Or you can always use a table of values. That will always work, okay? So now we have one last one to do. And if we look at this, the vertex is 2, 1. So you always start with the vertex. So I start with the vertex. I add 1, 3, add 3, 6, and 11. So I pick those numbers. Let's plug in these numbers. 3 minus 2 is 1. Square root of 1 is 1. 2 times 1 is 2 plus 1 is 3. 6 minus 2 is 4. Square root of 4 is 2. 2 times 2 is 4 plus 1 is 5. 11 minus 2 is 9. Square root of 9 is 3. 2 times 3 is 6 plus 1 is 7. So I can graph these values. Okay, I'm going to graph 2, 1, 3, 3, 4, 5, 6, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 1, 2, 3, 4, 5, 6, 7. Okay? And that is a stretch. But let's see if the shortcut method works. So, shortcut method says I go up A, which is 2, over 1. Up A, which is 2, over 3. Up A, which is 2, over 5. So I go up 2, over 1, worked. Up 2, over 3, it worked. Up 2, over 5, and it worked. So the shortcut method does indeed work, but you can either use the table or the shortcut. When you use the table, you always start with the vertex. Does not matter what numbers you pick, but if you pick numbers that make it a perfect square underneath the radical, just makes the math easier. Okay? So now in the next video, we're going to go over page 2b.